We're going to do triple integrals and spherical for this video. This is the first video. We'll have a couple of videos for spherical and at least one video for cylindrical. To review, point rectangular coordinates we reference with x, y, and z. Rho is the distance from the origin to a point. Phi is the angle this line segment makes down from the z-axis. And here project this point down to the xy plane to xy0. Theta is the polar theta. It's a counterclockwise angle over from the x-axis. You may recall we have these 7 equations. These 7 equations are all in your problem set. You can use them at will. We derived them earlier in the semester. Now it turns out if you take a small little volume element, I didn't really cloud the picture here by drawing d rho, d theta, d phi, but you end up with a small little section of a sphere. And it turns out dv is rho squared sine phi d rho d theta d phi. That's just a given. So anytime we want a volume integral, a triple integral, we're going to start with that. So here's a simple example. Phi goes from 0 to pi over 6, theta goes from 0 to 2 pi, rho goes from 0 to 2. We want to set up the volume, so it's going to be rho squared sine phi d rho d theta d phi. That's like starting out with dz dy dx. And these translate directly to the limits. Rho on the inside, 0 to 2, theta 0 to 2 pi, and phi from 0 to pi over 6. Sounds easy enough, but the question is, what volume did we calculate? Well, let's see if we can figure it out based on what's given here in the diagram, and then we'll draw a picture. Phi goes from 0 to pi over 6. Here's phi equals 0, here's pi over 6, roughly 30 degrees. So we're starting here and going down here. Theta 0 to 2 pi, we can go all the way around the z-axis, one revolution. Sounds like a cone. That's exactly what it is. It's a solid cone so far. Rho goes from 0 to 2. And so we're going to have, rho starts here, goes out to 2. We're going to have a spherical cap. And so the picture we have looks like this. There's pi over 6 equals phi. Theta goes from 0 to 2 pi. If theta went from 0 to pi, we just cut it in half. It would just be a half of, this is really a half cone actually. You may recall when we did 3D surfaces, a cone was actually a top and a bottom. You can call that a half cone if you want. So if you went from 0 to pi, that would be half of a half cone. But it would be half of what we normally consider a cone. And then rho goes from 0 to 2. That gives us this spherical top. That equation there is rho equals 2. That's nothing more than a sphere. You can make this a dotted line back here if you really want. So there we have it. We set up our first spherical integral.